Hello students, in this lecture also I am going to continue with the programmable peripheral interface 8255. So I was discussing about the operating modes of 8255 and in that I discussed about the bit set or reset mode, and I told you whenever microprocessor is going to send, as the control word is always sent by the microprocessor to the 8255, as 8085 microprocessor always sends the control word. Whenever I am saying control word means the data is being transferred from 8085 to the 8255. So whenever 8085 microprocessor is going to transfer any control word to the 8255, and in that control word if the most significant bit is 1, if the most significant bit is 0, then means that control word is for bit set or reset mode, and depending upon that, if it is 0 means it is for bit set or reset mode for setting or resetting the bits of port C, and which bit of port C is going to set or reset will depend upon the status of D1, D2, D3, and whether it will be set or reset will depend upon D0. Now next mode, as I've told you, the bit set or reset mode I've already discussed. The next mode is input output modes, and in input output modes we have three modes: mode 0, mode 1 and mode 2. So mode 0 is simple input output mode. So in this mode, port A and port B, as you can see here, port A and port B, they are used as two simple 8-bit input output ports, and port C as two 4-bit ports. So each port can be programmed to function as simply as input port or output port. Then we have mode 1. In the input output mode we have mode 1, that is input output with handshake. So in this mode, input or output data transfer is controlled by handshaking signals. So what are handshaking signals? Handshaking signals are used to transfer data between devices whose data transfer speeds are not same. For example, computer can send data to printer with large speed, but printer cannot accept data and print data with this rate. So computer has to send data with speed with which printer can accept. This type of data transfer is achieved by using handshaking signals. So these handshaking signals are used to tell the computer whether printer is ready to accept the data or not. If printer is ready to accept that data, then after sending data, what happens? Microprocessor first sends data to the data bus. After sending data to on the data bus, computer uses another handshaking signals ST bar. First of all, what happens whenever computer is going to send any data to the printer, tells the computer whether it is ready or not. Either it sends a busy signal or it sends the acknowledgement signal to tell the computer that it is ready for accepting the data or not. So once it sends the ACK bar signal, then it tells that it means that printer is now ready to accept the data. Then what happens? Computer sends the data on the data bus. Now once the computer sends the data on the data bus, it uses another handshaking signal ST bar to tell printer that valid data is available on the data bus. So these signals are the handshaking signals, which is used between two devices which are having different rates of working. So this 8255 mode, which support handshaking, has following features. The two ports A and B function as 8-bit input output ports. They can be configured either as input or output ports. In this mode 1, they are working as input output ports only, port A and port B. Now each port uses 3 lines from port C. As you can see here, this port C is this port C is divided into 2 parts, upper 4 bits and lower 4 bits. So each port, this port A and port B, uses 3 lines from port C as handshaking signals. So port A will be using 3 lines from the upper bits of port C, and port B will be using 3 lines from lower part of port C as handshaking signals. The remaining lines, the remaining 1 line of this port C and the remaining 1 line of port C will be used for simple input output functions. Now the next mode is mode 2. in mode 2, that is bidirectional input output data transfer. So this mode allows bidirectional data transfer over a single 8-bit data bus using handshaking signals. So this feature is available only in group A. Let me show here. This feature is available only in group A, means these ports. So group A with port A as the, here the port A is again working as the 8-bit bidirectional data bus, and PC3 to PC7 they are used for handshaking purpose. So in this mode both input and outputs are latched due to use of a single 8-bit data bus. For bidirectional data transfer, the data sent out by the microprocessor, whatever data is sent out by the microprocessor through this port A, appears on the bus, connecting it to the peripheral only when the peripheral requests it. The remaining line of port C, that is PC0 to PC2, can be used for simple input-output functions. The port B can be programmed in mode 0 or mode 1. When port B is programmed in mode 1, PC0 to PC2 lines of port C are used as handshaking signals. So getting my point, in mode 2 what is happening? This group A is only working, and in group A this is working as 8-bit bidirectional bus, and 8085 actually sends or receives data through this port A using the handshaking signals from this port C of group A in mode 2. So this was all about input output modes. Now let's see the control word for input output mode. So as I've told you, in input output mode we have three modes: mode 0, mode 1 and mode 2. So this is the control word that microprocessor is going to send to 8255, that is programmable peripheral interface. So whenever microprocessor sends the 8-bit control word to programmable peripheral interface, depending upon the most significant bit, if it is 1 then it is the control word for input output mode, and if it is 0 then it is a control word for bit set or reset mode. So if it is 1 means it is for input output mode. Now this D4, D5 and D6 they are used for group A. So if D4, depending upon the status of D4, depending upon the status of D4, D3, D4, D5 and D6, D3, D4, D5 and D6, they will be used for group A. So depending upon the status of D3 will tell you the upper part of port C, which is in group A, will it work as input lines or will it work as output lines, depending upon the status whether it is 1 or 0. Similarly for if D4 is 1, then port A will work as input lines. If D4 is 0, then port A, the 8-bit port A, will work as output lines. Now if D5, D6, depending upon the status of D5 and D6 will tell you in which mode this 8255 is going to work, or in which mode this port A and port C is going to work, whether it is mode 0, mode 1 or mode 2. Similarly D0, D1 and D2 will tell you about the group P, the status of D0, D1 and D2. Again the status of D0 will tell you the about the port C, whether it is going to work as input port or output port. If D1 is 1 or 0 will tell you about whether port B is going to work as input port or output port, and depending upon the status of D2 it will tell whether this group B is going to work in mode 0 or mode 1. So this was about programmable peripheral interface. I am ending this class here. Thank you.